So let's keep solving the question now. We said that we're going to find out those two values that we're interested in, but we are going to standardize them. We're going to convert them into our z values. So let's use this logic, right? This formula, so to speak, to find out those values. So we have here 531. Let's see, in terms of the z value, what kind of number are we going to have over there? So we go over here, this point. The z value is going to be the difference between that observation and the population mean divided by the standard deviation. We know that the population mean is 535, the observation is 531, so the z value corresponding to this point is going to be 531 minus 535, and we divide by the standard deviation, which is equal to 7 points. So divided by 7. What we will have is minus 4 divided by 7. Minus 4 over 7 is going to be minus 0.57. So 1 point over here, minus 0.57. Now we replicate the same method. Over here. One more point, we're going to convert into the z value. That z value is going to be, again, the difference between that observation, which is 539, right? 539 from the population mean of 535, minus 535, in terms of standard deviation. So we divide by the standard deviation of 7. Well, that's 4 divided by 7, meaning it's going to be positive 0.57. So just to exercise this skill, this point is 0.57 standard deviations lower than the mean, further than the mean. And this one is 0.57 standard deviations higher than the mean. That's how we interpret this. This is just showing by how many standard deviations the points are afar from the population mean. Okay, we said this one is going to be 0.57. Now the question is, how do we find this proportion? How can we use the z table in the right way? Well, the z table is giving us the proportions, the probabilities, when it is lower than a certain number. For instance, if you look at the z table and we check the probability of the z value being lower than minus 0.57, right? So let me write like that. Z is going to be equal to minus 0.57. That's what we research in our distribution. Well, that's going to give us this tail. This is the probability that is going to be. The probability or the proportion, same thing, remember? So that proportion is going to be given in the table. Now, if we check that table, the proportion of having a value lower than minus 0.57 is going to be equal to, hold on a second, I have the table right in front of me, is going to be equal to 0.2843. So let's write it like that. That's going to be 0.2843. Make sure to be comfortable to use the tables, right? Because that really matters in stats. Now, on the other side, if we look at the distribution, at the z distribution, we want to find out the value or the proportion that z is going to be lower than 0.57. It's going to give us this entire region. This is going to be that probability. So this entire thing, the red one, you see? I'm not going to color it because it's going to be too much coloring. But that entire thing has a proportion, a probability of 0.7157. 0.7157. Now, what are we interested in? We're interested in the middle one, in this one, the white one, right? So how can we calculate that? We're just going to subtract the entire red area from the yellow area, and we're going to be left with the white shaded area that we're looking for. Meaning that if we solve the math, we're going to have 0.7157 minus 0.2843, and that's equal to, hold on, I don't have it, let me just calculate it real fast. 0.7157 minus 0.2843 equals to 0.43. Hold on, 0.4314. That's gonna be the proportion that we're looking for. The answer key tells us the proportion is 0.28, so the answer over here is gonna be false, and we are done.